As we said earlier, we don't directly produce ozone in the troposphere. So we produce the precursors, which means mitigating tropospheric ozone has to focus on the precursors that lead to the formation of ozone, and methane produces 50% of it. So anything we do to mitigate methane is going to also help reduce ozone. Nonetheless, going back to our friendly CCAC website, tropospheric ozone has a lifetime of weeks, and the stratospheric ozone is good, absorbs UV. It's formed there by splitting of oxygen atom molecules by the UV, and then ozone itself also absorbs some bandwidths of UV, right? So troposphere is in the lower 10 kilometers, changes with altitude nonetheless. Tropospheric ozone is a major air and climate pollutant. It's also a global warming gas. It causes warming and is a highly reactive oxidant, harmful to crop production and human health. Ozone is known as a secondary pollutant because it is not emitted directly, but instead forms when precursor gases react in the presence of sunlight. So photolysis can work with methane, carbon monoxide, non-methane volatile organic compounds, and nitrous oxide to produce ozone. So precursors can be carried around the globe, which makes it a local and a global problem. And we can see here the various sources. We already saw a little bit before that in addition to the global warming, ozone damages plants and affects agricultural production through photosynthesis, reducing plants' ability to sequester carbon and reducing the health and productivity of the crops. Air pollution caused by ozone, over 150,000 premature deaths can be attributed to it every year. Millions more chronic diseases, particularly in the children and elderly, are caused by ozone as well. Moving on to HFCs then. The trends in HFCs and projections are not so great. So if we look at various regions and different sources like refrigeration and other HFC sources and air conditioning, you can see that there are various different contributions in different places, but nonetheless none of them really show a drop anytime soon, except that the Kigali Amendment mitigation scenario requires us to drop off the thousands of metric tons of CO2 equivalent by mitigating HFCs. We will look at Kigali Amendment a little bit later in another podcast, but basically it's an extension to Montreal Protocol. Montreal was focused only on CFCs and ozone hole, and then Kigali Amendment added HFCs. So that's very critical. The sources and residence time around 15 years, weighted by usage. There are many forms of it, many versions of it. HFCs are powerful GHGs which contribute to global warming. We will look at its global warming potential in a second. They are man-made fluorinated powerful greenhouse gases rapidly building up in the atmosphere. They are used as replacements for ozone depleting substances in air conditioning, refrigeration, foam blowing, fire retardant, solvents, and aerosols. So CFCs were bad for the ozone. HFCs came in as replacements but turned out to be very bad for global warming. The consumption by sector, here they are. Residential, commercial, and industrial air conditioning and refrigeration accounts for almost 50%, with mobile air conditioning, unitary air conditioning, foam agents, aerosols, fire extinguishers, and so on. Looking at the projected growth again, CFCs haven't quite dropped off yet, but by 2030 we expect that they should be all gone. But the use of HFCs is rapidly going because they are widely adopted as replacements for CFCs. And Here we are going from 2010 forward to scenarios. HFCs, not good news there, various forms, so we have to deal with it. The most commonly used HFCs, according to this paper, with global warming potentials and lifetimes from the IPCC 5th assessment report, which was released in 2014. You can see these are the various HFCs with different global warming potential. This is why when we talk about global warming potential, we say weighted by usage. Okay, so lifetime can vary quite a bit as well. Okay, so you can see the range here, 4,800 times the CO2 warming over a 100-year period. That's not good news, right? 1300, 3170, 3350, and the most benign one here is at 138 with the residence time of 1.5 years. And some of them are like 47 years, 38 years, and so on. So, overall, indicative list of low global warming potential alternatives to the high GWP HFCs for various applications, like in domestic refrigeration, commercial and industrial refrigerations, which tend to be pretty massive, air conditioners at room level or commercial office building type scale, mobile air conditioners like in automobiles. We talked a little bit about it before when we talked about reducing fossil fuel consumption, because the engines for mobile air conditioners in cars are driven usually by fossil fuels as well. Foams, the current refrigerants are here with their GWPs that we looked at, the huge range. Alternatives, isobutane, so there are some naturally occurring hydrocarbons which we talked about in one of the earlier chapters, already adopted by Baskins and Robbins, for example, but these are not completely universally adopted yet. So the actual solution that will emerge in the coming years actually depends, especially in terms of the access and the cost to developing countries. Okay, so HC600, isobutane, propane, isobutene, sorry, not butane, ammonia, propane, blends, and so on. I won't go into it. Methyl formulate, okay, some chemicals. They have much smaller GWPs. You can see 3, less than 5. This one is a bit bigger because it's still HFCs and HFC blends, so it can range from 1 to 1600, and these blends now 400 to 500, and so on. So huge range of options. It's not completely clear when they will become universally accepted at some level, or when a real replacement will be found that will be able to eliminate HFCs by 100% by 2030. That's the Kigali Amendment goal, and that's the intended goal that this chapter wants to go for by 2030.